Namaskar, welcome to Prakash on Basics. I am Prakash 𝘩𝘁. We have been talking of electricity for the last few days, and today we are going to look at the utilization of electricity at home. How do we use electricity? And why do we use electricity is very obvious. That is one of the best sources of energy that we have, and that is the one that is going to be converted into a variety of utility aspects within our homes. We are going to use it for every possible application at our residence, and therefore we must know a lot about the electricity in household usage. Please realize that in a country like India, for example, we generate around 416 gigawatts of power, electrical power, and this is utilized for a variety of reasons: household, industries, transport and communication, and so forth, street lighting and so forth. So that is the amount of electricity that is produced. Where is it produced? Obviously at the generation plants, thermal plants and hydel plants and so forth, and generators are used for it, turbines are used for it, something that I mentioned long back. The production of electricity is done at 1100 kilovolt and 50 hertz in India. Kilo is 1000, so 11,000 volts and 50 hertz is the way in which electricity is produced in these generators. Same thing in Europe and some of the western countries, and in the US and other countries it is around 13.8 kilovolt and 60 hertz. That is the way that electricity is generated there. And what happens? The electricity is produced. Do you carry it by the bucket and bring it home? No, that is not possible. It has to come through transmission lines, and anything that is brought along, like water that spills on the way, energy is going to be lost, and that is going to happen everywhere. As far as electricity is concerned, the rule is associated with a formula, that is I squared RT, where I is the current, R is the resistance, and T is the time. So if the current is doubled, the amount of loss is going to be double. If the current is halved, the amount of loss is going to be halved. So what is actually done is that the voltage, the electricity that is generated as at 11,000 volts is boosted up to a higher voltage by a device which is known as a transformer. In the transformer, the voltage and the current product remains the same. So if the voltage increases, the current drops down, and so when the transformer raises the voltage to about 220 kilovolt, it has raised the voltage by 20 fold. So naturally the amount of current loss has dropped by 1 upon 20 squared, that is 1 upon 400 times. So the amount of energy loss has been greatly reduced. In India, it's either raised to 220 kilovolt or about sometimes in high tension cables at to 400 kilovolts, and energy is brought from the production site to the city or to the village. Then there are substations. In a substation, the voltage is reduced to around 33 kV, and then finally through lines or wires it is brought close to your residence and finally brought down into your residence. In India it is brought down to 220 volt. In the US it is brought down to 110 volt. Countries like Japan it is brought down to about 100 volt. This is alternating current, AC, 0, maximum, 0, negative, 0 again. That is one cycle. 50 cycles per second is the rate at which electricity is being produced. This one cycle is corresponds to 360 degrees, and it is possible that this can be shifted a little bit by 120 degrees and another 120 degrees, and this is known as a different phase. So electricity is generated because of the multiple layers of coils in 3 phases, and it is this 3 phase form that is sent. In our house and residence, usually a single phase is what appears. So, my house might have one particular phase and my neighbor or next building might have a different phase. So, when there is power failure, the lights from my house are switched off, gone, while lights there are still on. That is because it is a different phase. So, that line is still working. But then my society has a water pump, that is a 3 phase water pump. So, that stops working, because whether the electricity is switched off here or there, the motor is not going to work. So, when there is heavy load, 3 phases are used, and when the load is pretty light like our residences, a single phase is good enough. Now, this electricity that reaches our homes is to be connected and circulated around in our homes through wires. What type of wires depends upon the current that flows through it. If the voltage is higher, like 220 in our country, the wires need to be fairly good enough. But if you are using 110, the thickness of the wires has to be double, because it has to carry more amount of current. So, in the US and other countries where 110, or Japan where lower voltages are used, the wires have to be thicker and more current capable. Reason for why this voltage is higher is because they felt 220 volt, this is one of the reasons, that 220 volt is a little more dangerous issue. So, let us stick to something that is manageable, which is 110 volt. In India, we use 220 volts, and the wire comes in, a pair of wires or 3 wires are brought inside, and then the wires are distributed within our house, and there are a number of sockets that are produced through which electricity can be tapped and utilized for either a fan, a fridge, an AC, a radio, a computer, so many other places, mixers and grinders and other utensils, which can be connected and removed if required. Electrical connections are of 2 types. They can be put in one single line, one after the other. This is known as series connection, and the second is known as parallel connection. All our household connections are parallel connections everywhere. The reasons are quite obvious. In a parallel connection, it is like number of roads connecting 2 different cities. From Bombay to Pune, let us say there are 8 or 10 different roads. If any one road is blocked, the others are still continuing, and the distances between the 2 of them is always going to remain the same. The same thing happens as far as electricity is concerned. The 220 volt that comes in, everything else is connected in parallel to it. So, the 220 volt remains the same for all of them. But if I switch on the light, current would flow through that light bulb. When I switch it off, it would get switched off. The current through the other branches is not going to be affected at all. The others can be switched on or off, like the roads, one could continue working and the others could stop, and so forth. That is why all connections are in parallel at our residences. Depending upon the load, that is the resistance of the device that you are using, more or less amount of current is going to be utilized, and all that current is finally measured and recorded in the meter at which the input is given. So, that is how the systems work as far as electricity and its utilization within the house is concerned. But how much electricity do you get in? It is measured in terms of what we typically call as 1 unit of electricity. That does not really make any concept clear. The product of voltage and current is the amount of power that is used, and power is energy per second, and that voltage into current is measured in terms of what is known as watt. and if the value is very large, it is measured in terms of kilowatts, that is 1000 watts. Now, if a particular electrical device is using a certain amount of watts, for 1 hour whatever is consumed is to be measured, and this is utilized and measured in terms of a unit that is known as 1 kilowatt hour. 1 kilowatt of power used for 1 hour is defined as 1 electrical unit as far as we are concerned. Kilo means 1000 multiplied by 1000. So, it is 1000 watts used for 60 minutes into 60 seconds, that makes it 3600 seconds. So, 1000 multiplied by 3600, so many joule of energy corresponds to 1 watt, and for that you have to pay according to whatever the meter bill is. If it is 10 rupees per unit, for 10 units it will be 100 rupees that you pay. When I was a small kid, the rate was pretty low, about 60 paisa in the beginning, and maybe about 1 rupee or something later on. So, that is the amount that you pay, and now the bill is pretty high, and so we say that electricity is very costly. Not really, because if you look at the numbers very carefully, it is 1000 multiplied by 3600, and if you convert it to mgh, the potential energy, and try to calculate the things, it works out that a 100 kg man climbing through a height of 3600 feet would consume the same amount of energy as 1 unit of electricity. That is the amount of energy. So, it is not really very costly. We have got used to saying that electricity is costly. In reality, it is comparatively very cheap. And the bigger advantage is that it can be converted into any other form. But the drawback is that whenever you convert it in terms of heat, the energy gets consumed very rapidly, and that is where the electrical bills begin to shoot. So, when you are using an AC, when you are using a heater, when you are using an electric iron, all these consume a very large amount of energy as compared to a tube light or a fan. Just to give you an idea, suppose you have a 40 watt tube light and it works for 24 hours. It will consume 1 unit of electricity, that is all. 40 into 24, that will give you the product, which is 1000 units of 1 kilojoule of energy, that is all. So, you will realize that the amount of energy consumed is comparatively less. Look at a situation where I am talking of a 4 kilowatt water heater at home that I use for bathing. If there are more number of people, I use it for 2.5 hours. So, if I use it for 2.5 hours, what I am going to get is 2.5 multiplied by 4, that makes it 10 kilowatts, and that is a very large amount of unit energy. So, it is this heat aspect. And AC, for example, anything that has greater wattage is going to consume greater amount of energy. Please keep that in mind, and you can control things properly and reduce your costs of electric bills. What happens to the electricity that comes in? There are few things that we must keep in mind. We talk of the value as 220 volt that comes in, and this is AC, alternating current. What it means is, it is going to go from 0 to a higher value, come back to 0, go to a corresponding negative value, come back to 0. That is one cycle. 50 times a second this is going to happen. So, correspondingly, because of this voltage, certain amount of current flowing in the same manner will also flow through the device. And when current flows through a device, I told you some time back that I squared RT is the amount of heat that is going to be generated. But if the current is rising and falling, the amount of heat generated is going to also rise and fall, and it is independent. Whether it flows like this or like this, the wire is still going to get hot. So, an alternating current flowing through this particular device is going to heat not to its maximum, but to some average level. To obtain that average level, what steady current and voltage should I have applied? That value is known as RMS value or root mean square value. And when we talk of 220 volts, it is this 220 volt RMS that you are getting. So, in reality, the voltage is going from 0 up to 288, 0, minus 288, back to 0, 50 times a second. Its average effect is as if 220 volts was passing through steadily. So, whatever any meter measures is this steady state value, or the it is not steady really, it is RMS. RMS means root mean square value. This is the RMS value. And then how do you get the peak value then? And that peak value can be obtained by multiplying this RMS value by root 2, and that works out to be around 288. So, the voltage fluctuates between plus 288 and minus 288, and the average effect of it is like 220 volts. So, we say that we have electricity at 220 volt. So, we have electricity at 220 volt and the corresponding amount of current that is available, and that is available for you to utilize at home. So, what is the next step? We put it to use. But the trouble is, whenever we try to use electricity in this sort, the amount of electricity used will depend upon the load, and there is one wire through which energy is coming, and it is said that through the second wire the energy is to be dissipated back again. These wires are identified as live and neutral. You cannot say in true sense that electricity comes and goes. The things are a little more complex, slightly beyond our discussions here. But how do you find out which is live and which is neutral? There is a device for it, and that is known as a tester. A tester is like a screwdriver with a diode fitted in between. When you put one of the ends of the tester inside the socket and touch the base, if it is the live wire, a very small amount of current flows through the diode, through your fingers to the earth, and the diode begins to glow. So, whenever on contact with the wire the diode glows, that wire is live. You try it at the other end and it does not glow, and so that wire is neutral. Whatever is connected between the two of them will consume electricity, and that is the load. So, you put in a 2-pin inside and there is a fan connected to it, so it begins to run, or a lamp connected to it and it begins to glow, and so forth. But by chance, if these two wires come directly in contact with each other, then there is no load in between, resistance is 0. So, what will happen to current? Current will shoot up, it will go to maximum, whatever is available, and I squared RT will tell you the amount of heat generated, and the effect will be burning. And this is typically what is referred to as short circuit. So, when there is no load and the live and the neutral come in contact with each other, what you have is a short circuit. And this could happen because of a variety of reasons. Somebody fiddling around and putting something between the two socket pins, and there is a blast and fuses blow out and there is a short circuit. Or the house is very old, 100 years old, and there is 100-year-old wiring, and there is water dripping everywhere, and the wires are all eaten up by rats, and sometime the live and the neutral come in contact with each other, and there is a burning sensation and everything goes off, or there is a fire. That is short circuit. How do we prevent this? There are two ways by which this can be prevented. The first method is to use another path for the electricity to drain off, and that is provided by the third terminal in the socket, which is known as the ground. So, there is a thick wire from the ground that is actually taken and connected to the ground. You put a metal plate and some salt and etc. and dump it inside the ground. In olden days, it used to be connected to the household piping, because the pipes were all of metal and they finally used to go to ground. Nowadays, plastic pipes, and you can't do that, so you have to actually have a ground inside. So, if by chance if there is a short circuit, instead of the current flowing through your body and some other way round, or through the instrument's cover and other areas, it flows through this wire directly to ground, and there is no problem that is caused. There is a second issue that can be used to tackle this problem, and that is using a device known as a fuse. Immediately after the meter, there is a pair of wires that comes in, and there are two small boxes known as the fuse boxes. Inside the fuse boxes, between 2 points are connected 2 wires on either sides. Usually 2 I will come to, but one of the wires is what we are talking of just now. The wire is usually made of soft metals which melt at very low temperatures, like tin and lead, a combination of the two of them. So, these wires are specially designed. They are typically known as fuse wires, and they are rated. So, suppose a wire is rated for 5 amperes. That means, whenever 5 amperes of current flows through it, nothing will happen. But whenever the current increases from 5 amperes to 6 amperes, the wire starts getting hot, and since its melting point is low, it melts. So, the wire is in contact like this. The instant it gets hot, it breaks, and so the current flow is prevented and it is stopped. So, the fuse burns off and the current is stopped. But suppose the current was put in the neutral and you had touched the live when the fuse circuit was completed somehow, you are still going to get a shock. So, many times there are 2 wires that are put, one here and one there, and so both the fuse wires blow off and you are then very safe, and the whole house or the system is cut off from main supply or the main source of energy. Every time replacing these wires is not really very convenient. So, they thought of alternatives, and the alternative very typically is a trip type of a fuse that is used very often. It consists of a bimetallic strip. These strips are made of 2 metals, and when the current passes beyond a certain limit, they bend, and the instant they bend, the contact is lost and the switch trips off. In some cases, they cool down and the contact is re-established and the current begins to flow, and the instant they get hot, it breaks off again and the process continues. These are all typically known as the thermostats. They control the temperature. They are used on all those electric irons when you change from cotton to silk and rayon and others. What you are doing is you are changing the tension on this plate and deciding the amount of temperature that the electric iron can reach. But the trip once they bend, they will not come back on their own. So, you have to repair whatever is the fault and then reset the whole system once more, and that is how it works. So, this is a fuse, that is another protective device. And in case of some very typical electrical devices, there is a very small capsule as soon as the wires come in, and it is on the base behind somewhere. It is a circular disc. You unscrew it and there is a glass cartridge inside, and these are known as cartridge fuses, and there is a fuse wire inside. So, if it is rated for 5 amperes, anytime the current goes beyond 5 amperes, it will fuse off. So, you replace it with another cartridge, and so the TV is protected and so forth. So, that is how fuses work. And so, fuses are used to protect the systems and protect humans also, because humans can be affected by electricity. Our body works on electricity is an issue I am going to tackle on much later, because all our nerve signals are basically nothing but nerve impulses, are voltages up to 1 volt, 0.1 volt. But if I touch a live wire, my body resistance is pretty high, but still the voltage there is 200 volts and my body signals are only 0.1 volt, that is 2000 times higher. Naturally all these signals are going to be overridden and my muscles will not be able to move, I will be stuck there itself. And if the current is very large because of various reasons, I could be electrocuted or burnt off completely. If there is liquid of any sort, the salts dissolved in it will make the body extremely good conductor of electricity, and then the current will rise rapidly and I squared R will rise and the whole system within our body will collapse and break down. That is electrocution that really happens. So what do? You make sure that your contact between you and electricity has a very high resistance. These are all known as insulators. So you put a rubber glove or wear rubber slippers so that the ground and you are shielded from each other through a rubber, so the circuit is not complete, and if the circuit is not complete, it is not going to cause any harm. That is why a parrot can sit on an electric wire and not get electrocuted, while a person who tries to climb up and touches two of the wires and shorts them through his body is just converted into charcoal. So electricity is unforgiving. You have to be very cautious and you have to take necessary care. There is one more issue sometimes that is talked of. If you have not experienced an electric shock, it is fun, but do not try putting your fingers to a neutral wire or to a live wire. A 9 volt square battery, if you touch it to your tongue, you can realize what a shock is like, a very mild tingling sensation that is there. But if the shock is, because people say that you get thrown off by electricity and some people are stuck, what really happens? If it is AC, alternating current, 50 times a second the voltage is going to come down to 0, and if your body can react fast enough in that fraction of a second when it is to 0, all your muscles will try to break away from the source of the problem and you will feel as if you are being thrown off by the electricity. And if it is DC, you can't do anything because that voltage is still going to be around, and you are, once you are stuck, it is gone. It is like touching a very 30-40 volt of car batteries or big ones, bigger batteries. So that is pretty harmful. There is one more issue in this. People say that using wood to remove, this is a practice in India and various other cities in villages, etc., must be known. Using wood to break away people from live wires, etc., is tried. Good enough, because wood is an insulator. But you cannot hold a wooden stick in your hand and try to free the other person with your other hand. It is not going to work, because he is having electricity going through him. It will then start flowing through you and ground also. Stick in the hand is of no use. So it has to be between the path or in the path of electricity, between you and the ground, and only then you will be saved, or you and the neutral, and only then you will be saved. So you need to be very cautious as far as electricity is concerned. But then there are so many other instruments that work on electricity. How do they function? We need to understand them also. But that I don't think we will be able to talk of today. Whatever I have talked of today, if you have liked it, please put it to practice, because electricity is a big tool and you have to be cautious with it. You have to be careful. Tell this to your friends, tell this to your people who are known to you, tell this to the children. Be aware yourself. And how devices use electricity and work is something that we will talk of next time. Like this channel, subscribe to it, tell your friends. Until we talk of the instruments and other devices that work on electricity. Namaskar.